Hey guys, today we're going to be taking a look at fractions. Mathematically, a fraction is a numerical representation indicating the quotient of two numbers. So in non-geek speak, basically a fraction is a way of telling how many parts we have. So let's take a look at what this actually looks like mathematically. So the first thing that we want to do is we want to tell what the size is of the parts that we have. For instance, I have a candy here. And I'm going to take a minute and draw this candy and split it into 4 separate parts. So mathematically, what I've done is I've created a fraction with a denominator of 4. Now the denominator is a size description. So when you think of a fraction, think of the fact that the denominator is telling you how big our parts are. In this case, we have 4 because we divided our candy into 4 parts. Now, the numerator is what's going to tell us how many we have. So the numerator tells us the number of parts that we have. So in our example here, let's say that I want 3 parts. So I'm going to shade 3 of these parts here. 1, 2, 3. So I would put 3 in for my numerator. So this fraction would be 3/4. I have 3 out of the 4 parts I've divided the candy into. So remember, the numerator tells how many parts you have, and the denominator gives you a size. One of the things that makes fractions tricky is that we have equivalent fractions. It's the idea that a fraction can be written in several different ways and still be the exact same amount. Let me show you an example. Let's say I have a candy and I want the whole candy. So I want 1. So I'm going to take a minute and I'm going to go ahead and shade my candy here to show that I want the whole thing. Now I could write this as just the whole number 1. Or maybe I want to write it as a fraction, and I know that my size is 1. I took the candy and divided it into 1 part, and I have 1 of those parts, so 1/1. I could split the candy up. Now I have a size of 2 because I divided the candy into 2 chunks, but I have both of those chunks, so I have 2/2. I could divide the candy again and make it 4 chunks, in which case I have 4 chunks out of the 4 that the candy is divided into. I could even divide it again and give myself 8 different parts and say that I have all 8. So there's a multiple of ways that we can write the same fraction. Now I want you to notice that anytime the numerator and the denominator are the same, we actually have a whole amount. Let's take another look at another example. So down here I have a candy, and I want to start by showing that I have half of the candy. So I'm going to divide it in half, and I'm going to shade just the bottom half to show that I have 1/2. And of course I can write the fraction as 1/2. I could divide this up again, like we did above, and let's say this time we divide it into 4 chunks. Well, I have 2 of those 4 chunks, so I have a fraction of 2/4. I could divide it again and divide it into 8ths. And if I count it up, I have 4 of those 8 sections. 1/2, 2/4, and 4/8 are all the same fraction. Now, I don't want to have to get out a candy and draw a picture each time I want to figure out fractions that are equivalent. So what I'm actually doing here is, if you notice, when I go from 2 to 4, what I actually did was multiply by 2. And I did the same thing on the top. 1 times 2 is 2. When I went from 4 to 8, I multiplied by 2. When I went from 2 to 4, I multiplied by 2. I could even multiply by something different than 2. Let's say I multiply by 3. Well, 8 times 3 is 24. And 4 times 3 is 12. It doesn't matter what number you multiply by. As long as you multiply the top and the bottom by the same thing, you will get an equivalent fraction. I could even divide the top and the bottom by the same thing and still get an equivalent fraction. let's say that I divide the top and the bottom here by 6. 24 divided by 6 is 4. 12 divided by 6 is 2, 2/4. All of these fractions are the same amount. So just remember, multiplying the top and the bottom by the same amount will give you an equivalent fraction. In the same way that dividing the top and the bottom by the same amount gives you equivalent fractions. Adding and subtracting fractions at its basic level is not a very tricky idea. Basically, if the size is the same, so if the denominator is the same, then all we have to do is add or subtract the numerator. Let me show you what I mean. So here we've got 1/4. So I'm going to take my candy and I'm going to divide it into 4 sections. And I have 1/4 of that, so I need to shade one of those sections. Now I want to add to it 2/4. Well, my candy is already divided into fourths, so I'm just going to shade 2 more sections. And when I'm done, I just count up the number of sections I have shaded, which is 3. And then I write down the size, which is 4. So notice I just added the top numbers, the numerators, but my bottom number stayed the same. Because when you add things, you don't change the size of what you're adding. You just get more of them. So adding, subtracting things changes the number of the things rather than the size of the things, which is why your bottom number, your denominator, will always stay the same. Unfortunately, we don't always get fractions that are given in the same sizes. So if the size is different, if the denominator is different, then we need to find equivalent fractions so that the size is the same, because it's really hard to add things that are different sizes. So here, I have 1/4 plus 1/2. So if I take my first candy here and I divide it into 1/4, and I shade one of those parts, and I take my second candy and I divide it into a half, and I shade one of those parts, it's hard to figure out how I should write my answer because the sizes don't match up. Now what I could do is I could write my final answer in fourths. Now my first candy gave me a size, a number of 1. My second candy, if I had divided that up into fourths, I noticed that I would need to shade 2 sections. So what I'm going to do for my answer is I'm going to shade 2 sections. So what I actually did here is I took my 1/2 and I rewrote it. I rewrote my 1/2 as 2/4 to get an answer of 3/4. You can't add things that have different sizes, different denominators. But what you can do is you can rewrite your fractions using equivalent fractions to find fractions that you can add together because they do have the same size. So all I did was took my 1/2, I multiplied the top and the bottom by 2 to get an equivalent fraction of 2/4, and then I added. Let's show you another one. Let's say I have 2/3. So I divided my candy into 3 sections, and I shaded 2 of those sections. And I need to subtract 1/2. So I'm going to take my second candy, divide it in half, and shade one of those sections. Now the problem is figuring out how much I have left over when I subtract these 2 amounts. And there's not really a way to do 2/3 minus 1/2 and tell how much I have left. So what I'm going to do instead is I'm going to do a little bit of rewriting. I'm going to think of each of these as divided into 6. So this first one, I'm going to divide it into 6 parts. And my second one, I'm going to divide it into 6 parts. Now when I look at it, I see that over here, I have 4 out of 6 parts. And the second one, I have 3 out of 6 parts. And I'm trying to subtract them. Well, that should give me 1 out of 6 parts. So I'm going to end up with an answer of 1/6. Now to make this short and easy, my 2/3, this one, I multiplied both the top and the bottom by 2. My 1/2, I multiplied both the top and the bottom by 3 in order to get the equivalent fractions of 4/6 minus 3/6. Then I can write my answer as 1/6. So before you subtract or add, you need to make sure that your sizes are the same. And we do this by rewriting the fractions so that they have the same, a common denominator. Sometimes when we're adding and subtracting fractions, we get more than 1 for an answer. For our example here, we have 2/3 plus 1/2. So if I sketch these out, on my first candy, I am going to divide it into 3 chunks, and I need to show that I have 2 of those chunks. On my second candy, I'm going to divide it in half, and I'm going to show that I have 1 of those chunks. Now clearly I can't add these two just looking at them the way they are, so what I'm going to do is take a minute and write them with a common denominator. So I'm going to make sure that each of these is written as 6ths. So I have 4/6 on the first one, and I have 3/6 on the second one, which gives me a total of 7/6. What this would look like is I have a whole and 1/6 of a leftover. We could write this as 1 and 1/6. When we write it as 7/6, we're writing it as an improper fraction, a fraction in which the numerator is greater than the denominator. The top number is bigger than the bottom number. If we write it as a combination of an integer and a proper fraction, so we have the whole number 1 and the fraction 1/6, that's what we call a mixed number. 7/6 and 1 and 1/6 are the exact same amount. There's different ways of writing the information. One of the things we need to be able to do is switch back and forth between improper fractions and mixed numbers. So here I have an example of the improper fraction 11/3, and I know that's equal to the mixed number 3 and 2/3. The question is, how do I get from 11/3 to 3 and 2/3? One way to do it is to write a series of addition problems. So here I have 3 and 3/3 plus 3 and 3/3 plus 3 and 3/3 plus 2 and 3/3. Now if I add all these guys up, I end up with 11/3. But a different way to think of it is 3/3 is the whole number 1. Remember, anytime my numerator and my denominator, the top and the bottom, match up, we get the whole number 1. So what I really have here is 1 plus 1 plus 1 plus 2/3, which is equal to 3 and 2/3. So I could do it with a repeated addition, or I could do it with division. So 11 divided by 3. I'm just going to use long division to divide this out. I know that 3 goes into 11 3 times for a total of 9, which gives me 2 leftovers. Anytime that you have a remainder in a division problem, we write that as a fraction with the remainder over the number you divided by, 3 and 2/3. Both ways work. Now if we're moving the other direction, we're moving from the mixed number to the improper fraction, we can use the same idea. We could say that the mixed number is 1 plus 1 plus 1 plus 2/3. Since we have a 3 here, let's rewrite all of our 1 plus 1 plus 1s as 3 over 3. So I have 3 over 3 plus 3 over 3 plus 3 over 3 plus 2 over 3. That's going to give me a total of 11/3. There's my improper fraction. Or, a shortcut method, I can do 3 times 3 and add my 2 in. If I multiply these two numbers, I get 9, and I want to add in the 2, which gets me 11/3.